Consider this: where are all the aliens? The universe is vast, teeming with billions of galaxies, each home to billions of stars. The numbers alone suggest that we should not be alone. Yet despite the high likelihood of extraterrestrial life, we have not found evidence or made contact with other civilizations. This perplexing contradiction, the gap between the expected and the observed, the question of our cosmic solitude, is known as the Fermi Paradox. This conundrum is what we know as the Fermi Paradox. To understand the Fermi Paradox, first comprehend the vastness of the universe. That's easier said than done, isn't it? The universe is staggeringly, mind-bogglingly big. We're talking about over 2 trillion galaxies, each one teeming with an average of 100 billion stars. And around at least a fraction of those stars, there's a good chance there could be planets just like ours, potentially capable of supporting life. The Drake equation, named after the astrophysicist Frank Drake, provides a mathematical approach to estimate the number of civilizations in our galaxy, the Milky Way, with whom we could potentially communicate. This equation takes into account several factors: the rate of star formation, the fraction of those stars with planetary systems, the number of planets that could potentially support life, the fraction of planets where life actually develops, the fraction of life that evolves into intelligent beings, the fraction of civilizations that develop technology that releases detectable signs of their existence into space, and finally, the length of time such civilizations release detectable signals. Just imagine, with so many galaxies, and each galaxy containing so many stars, and around those stars so many planets, the numbers quickly become astronomical. Even if life is a 1 in a billion occurrence, the universe is so vast, so incredibly big, that we would still be talking about hundreds, thousands, perhaps even millions of civilizations out there. And yet, nothing. No signals, no visitors, no obvious signs of interstellar engineering. We see a universe teeming with potential homes for life, and yet, we appear to be alone. This seeming contradiction between the high estimates of potential extraterrestrial civilizations and the lack of evidence or contact with such civilizations is what's known as the Fermi Paradox. Given these numbers, it seems we should have already had contact. This is the crux of the Fermi Paradox. So, where is everyone? Are we truly alone in this vast cosmos? Or is there something we're missing? This, dear listeners, is the enigma that keeps scientists up at night. Various solutions have been proposed for the Fermi Paradox. One of the most compelling is the Great Filter hypothesis. This theory suggests that somewhere along the evolutionary timeline, from the emergence of pre-life to the development of a Type 3 civilization, there lies a formidable barrier, a great filter. This filter is so challenging to overcome that it prevents virtually all life from progressing further. Picture it this way. Imagine life as a grand cosmic marathon, where countless civilizations are runners. The starting point is pre-life, and the finish line is a Type 3 civilization. A society capable of harnessing the energy of an entire galaxy. The path between these points is fraught with potential pitfalls and barriers. These are the great filters. Some scientists speculate that these filters could be catastrophic events like nuclear war, pandemics, or even self-inflicted ecological disaster. Others propose they could be natural phenomena such as asteroid impacts or gamma-ray bursts. The key question here is, where is this filter located? Is it behind us, meaning we've already navigated the most challenging part of our cosmic journey? Or is it still ahead, representing an insurmountable hurdle that could spell doom for our civilization? The unsettling part is that we don't know. We don't know if we've already passed the most difficult part of the race or if the hardest part is yet to come. Could we have already passed this great filter, or is it still to come, potentially dooming us? The solutions to the Fermi Paradox don't end with the great filter. Let's delve further into other compelling theories, such as the zoo hypothesis. This idea suggests that we, humans, are essentially like animals in a cosmic zoo. Extraterrestrial civilizations might be out there watching us, studying us, much like how we observe animals in a zoo. They could be purposefully avoiding making contact, waiting for us to reach a certain level of technological or societal development. Now imagine a universe where civilizations are abundant, but everyone is silent, almost like a cosmic game of hide and seek. This concept is known as cosmic silence. The theory suggests that advanced civilizations may be purposely avoiding communication, perhaps due to the potential risks associated with revealing their location and existence. Maybe they've learned from their past, or from observing others, that shouting out into the cosmos isn't always the best idea. These theories, while fascinating, are but a fraction of the many ideas proposed to explain the eerie silence in our universe. They each offer a unique perspective on the paradox, and while we may not have concrete answers, they continue to fuel our curiosity and drive our search for extraterrestrial life. These are but a few of the many theories that attempt to explain the Fermi Paradox. The Fermi Paradox forces us to examine our place in the universe. It compels us to reckon with the grandeur of the cosmos and our seemingly minuscule position within it. This paradox, a conundrum wrapped in an enigma, has been the subject of many a late-night discussion and profound scientific investigation. The implications of the Fermi Paradox are far-reaching and thought-provoking. If there are indeed countless civilizations out there, why haven't we heard from them? Are they too far away? Are they avoiding us? Or perhaps have they already come and gone, victims of their own technological advances or cosmic disasters? This paradox also compels us to look inward, to question our own species' future. If the Great Filter hypothesis holds true, we must wonder whether humanity has already passed this filter, or if it's yet to come. This could signify our doom, or indicate that we are among the rare few who have managed to survive. Or maybe we are alone, a cosmic anomaly in a universe filled with silent stars and barren planets. This idea, while somewhat melancholic, also underscores the unique and precious nature of life on Earth. While the Fermi Paradox raises more questions than it answers, it serves as a humbling reminder of our small place in the cosmos and the mysteries that remain unsolved. As we continue to gaze at the stars, the quest for answers persists, driving us to explore and understand the vast enigmatic universe we call home.